solving real world challenge, Ruby Ractor. Welcome, Hiếu Nguyễn. Yeah.
Hi, so my name is Hiếu. My first name is my last name is Nguyễn. So I'm going as Hiếu KZ9 everywhere on the internet. So today we will talk about real world application of Ractor. So today we discussed about like high performance XML processing, XML and Ractor. And I see that some people are asking questions about that usage and potential challenge of Ractor. Hopefully, like today, I can share some insight about that. So before like going to a talk, I introduce myself. Currently, I'm a senior engineer lead of the application team, and after that, we be building quality service for financial institution. So we simply then and then you converting the you're collecting the miles from the credit card, like the from credit card, and then you're using the points to change for gift card or like cashback, changing the points to like miles. Then it's most likely that you are using service that powered by our center. So we are mostly building by using Ruby with framework Rails or Hanami. So today then we will first about Ractor, what it is and what it is, right? And after that we will talk about the use we are using it in a center. So we just try recently, so we need to find a suitable use case. Currently used for like encrypting the user personal information. Then there's some like how the like and some benchmark to see like what performance and some of the lessons that we learned. Okay. To give some context, so when developing Ruby 3, then Matt set a goal for it to be like 3x faster than Ruby 2. With the application of like just in time compiler, it then like with the Opcarot mark, then we reach the that we set, and I together with those important performance optimization, then there is also another addition which is like fiber and Ractor or like comparison. So in the era of like core machine, then currently with GIL, and we cannot utilize all the power of our CPU. Ractor, then it like using machine much utilize much better. So to talk about like how Ractor can so like you can see that there is one first, and like first can chop and stir, and after it stir the pot, then it weigh a bit the, and when it then it another work in chopping. So in this, then you can see that you can do simultaneously like chopping and sorry, but then there's only one person, and the octopus can only do one thing at a time. Seem to be like, but like only one work in that. So it's very similar to our Ruby process work. Like at one time, you got only I think once you can run in one process. So like we can compare it to second illustration here when we have first, and at this time then like it can how Ractor can have like one of the core that we can have in our machine. So this is benchmark that we do application. So this is like graph of like the number of jobs that we job that run for encrypting the performance. So before then, average like 250 per minute, and after that, then after improving, then we run like I think an average around 100 job per minute. So it's almost double number. So like how can Ractor like help us achieve it? So we need to look into like our concurrent primitive that currently implemented. So for example, like in thread, right? Like if a project then we spin up some thread, then even though those threads are running in concurrent, then they still have global interpreter lock with GIL. So that global interpreter used for protecting the memory that like all the thread access, so that the data can be like consistent. Does it mean by like consistent data? We can see a example here. So we have an array and then a spin out up like 10 threads to inject the array. Add an element to the array, and then after that I like finish on the thread and I print out the array content. So you can see no matter how many times you run it, have like always have like 10 elements inside the array. It can have a different order, but like always 10 elements. If we run it in, for example, in JRuby, and we have differently, like you may have 8 element only. The reason is like in other language, like they have the JI, so there can be array condition. The array can be set with like different of like it cannot be protected and break. So Ractor was introduced to like go back a bit and like, but not every time that we need to have this kind of like protection against our data. Or if we only need to read data, we never mutate the data, then we don't really need the IO, because like we don't like edit any data, then they know data consistency still. However, then with model, then even though we only read, we still need to go to the GIL, and that prevent us from more with our machine. So Ractor like solve this problem by create separate memory for each of the Ractor. So in this case, there is, you can see here that they don't share GIL for every Ractor anymore. And so in this case, each Ractor will have a simple GIL. Then it will have like its own memory, so it can access very freely. And each machine, CPU can like access for that. And for them, if we have 4 core, in this case, 4 CPU can run, can 4 Ractor in parallel. So if they have shared memory, then like how can we control and then communicate between each? One way we can do it is like by sending and receiving messages. You can see later. So to sum up, then Ractor like have view that is isolated. It have separate memory, separate GIL, and then use message-based communication, right? Only sending and then receiving data. Not like share memory, and then it's quite lightweight. Like in contrast of like previous when like a single one with OS, right? In this case, then Ractor can be like a few Ractor can be managed OS only. Like we have scheduler now, we 3.3. So Ractor is much more lightweight than previous implementation of thread. So because of all of the attribute, and now it can have a simpler concurrency model with better performance. So few drawbacks that prevent it from used widely for now. So one major thing is like error. This one thing you see whenever you use Ractor. So it's still experiment. Lot of change can still happen for the implementation, and there are still a few implementation issues. We have encountered quite a few that we will bit later. A few more drawback is like the interface can be a bit familiar with people who are using only Ruby now. Like you said before in Java, and you may see some similarity here. But then if you only use Ruby, then maybe it's a bit difficult. And currently there is, I think, tuning support now, like all of library currently support. So a lot of things you need. So we will come to like the use case that we use to apply Ractor. So in our authenticated team, then one of the concern we usually need to deal with the user side that they care about their personal information. They don't want that like we display them or like we link them to like external function. So we tell them that okay, your data will be encrypted within our database. No one will be able to access them except some like our user. So, but then like we need to have like another kind of user, which is our business admin. So business admin be like, for example, the CS, the customers who we need to have the customer with the, and usually they will need to search for the customer using some like personal information, personal identification. And if you encrypt the use like all not the personal info, then it will be very hard to, especially like if you do like transfer. So in this case, then lemon attack called blind that would help the our system easily, but still allow like the data is not available in it. So the algorithm is quite simple. It's just like, for example, PI is a text, right? A text will be processed into some NRAM token, and then the NRAM token will be hashed by algorithm, hashing algorithm. And I go for like big grips to like blind that token. So the input when the people search, and similarly, like they will also be fed into like NRAM token again, and then like the token can be matched with the blind that in our DB to find the user. So the why is suitable for Ractor application. Like all of these process is U intensive. So the hash algorithm be quite slow. So we configure the hash algorithm to be at least 200 milliseconds, like 500 milliseconds. So that the attacker cannot really run a rainbow table and then own up the combination of the key and then the check with the data. Because CPU intensive, so with the current implementation of thread, then like even though we parallel it, process will be pretty slow. So our existing solution to like use like multiple core is so like the process is for example like every day the bank will like give us some batch user, like usually around like 200,000, and then we will do some job to our psychic, and for each user and usually we will do a job to like encrypting the user data create the blind index. So this solution works quite well for us so far. So it's psychic is very major and reliable. We if there any issue that it can just retry, and like it's scalable to some extent. Like we have more, we can just adding more container, increase our machine presence. The problem is like overhead on the psychic job. So for every single user, then we need to like fly it from the DB to every job. We need to create a record in Redis, and then we need to delete that record after the job finish. So there is some overhead. Small but still that can cause a problem. And at sometimes the CPU can be underutilized. For them, like we can like for example, process in 1 hours container, but then because of cyclic implement, like it can put all the job into a single process, and then, like we cannot use like core. So sometimes like the number of job is more than we utilize one of our core. So the code for it, like this is simple version, but usually quite simple. Basically, we have a part here where we generate the token. We use a class based on the string, and after every token is finished generating, then we set in the DB. So when we receive the user from the bank perform a bug job to we just give user perform bug. So it really is a bit complicated, but this is like the quite fit with what we have. So in order to apply Ractor, then we only need to change. Yeah. So instead of like enqueuing a job for every single user, now we encrypt. Now we match up user job with a backup user. We experiment with a few job with like 100 user, then we give. So in single job, we can hit, make for each user, and then each user can be processed by Ractor. After like processing successfully, you can save it to DB. So I think for like it's just a small change compared to like what we have in so when we try approach this, then we have a few try to have no mutable action in Ractor. We try to avoid blocking, and only time we send the message, so we will get back to it later on why. So when we apply that, then the code is like this, very simple. So the generate token is the same, save to DB is still the same. Using the user repository to update. So the only difference now we create a new Ractor for every user. Now we for every new user, then we create a Ractor. And after we create all Ractor, then we expect to thread. Like thread, we need to join them, then we just give take for every Ractor, and then we can get out the data they possess. So the result is quite surprising, like few errors. So like luckily then they spell a test, so never get. But then it's quite surprising first. The problem here is so first of all, like the constant, if they are mutable, then you cannot put it in. Like if the like so what is the mutable constant, like not number, not frozen string, frozen array, or frozen object, then it cannot be put into. So it is quite reasonable because like so it is quite easy to fix it. The second thing is a bit more tricky. So like if any method that accept like global state or accept something that is mutable, then it cannot be called in character as well. So this is a lot more tricky because we own a method of somewhere that we cannot really be sure that like this method is actually any global state. So go back to this. Then there are two places. First is the constant here. So the constant here is like we just have to like freeze the array at the rate quite simple. The second one is more surprising. So the error for the mutable method is user too hard. So you can think that like too hard is actually a very stylish function. It doesn't accept anything. But then like actually in this case then we do accept something with because like our user data is encrypted. So we need to accept a key from a to get a key. And then like we need to avoid like DDoS service, so we need connection pool. So any actually the connection pool with a global with like this is quite surprising, and then it causes error. So the solution is can be very simple sometimes. So in this case, luckily first it's because like it's directly inside the code that you Ractor. So we can just move it to like to outside Ractor and then set data inside. But then sometimes like it's more difficult, like for example inside the blind generator, for example, then it may be quite hard for us to extract it out. So in this case, then we just update it to send the mutable data inside Ractor, and then it worked quite well. So in the end, we have a simple benchmark job with 100 users, and we got like I think in our core machine it got 3x faster. So, but like this is just an initial application. So in the future we intend to add more. So there are a lot that with the current implementation that does not have in the previous one. So one example is currently for a single job, if we fail the job previously, then we can retry a single one without any problem. So now fail, then we need to retry a user that one. So it can be tricky, especially like if you have some issue that got lots of retry. The second thing is we handle the error inside Ractor. Like even if like some Ractor is successful, just a single one fail that can cause the problem for the whole batch. Like there is some improvement that can make even faster. So is like we can get a response from the Ractor faster using like Ractor select. But currently, I think the talk quality from in July, they said that this proposal for performance of Ractor select from ON 01 is not accepted. Currently, like one we still haven't used it. So what it does is like it can accept like Ractor here, that we create here, and then it can get the first like if any of them finish, they can get it immediately. Rather than in my current process, I will to wait for the first Ractor to finish before I go to the second one. So in this case, then if the first Ractor is very slow, then it can give the result much later. The Ractor much later. On the other hand, if I Ractor select, then like any I can process first because like okay, I don't care about the other output. Last thing is about saving progress. So like if any Ractor finish, and I can save it in DB already. I can match the progress, and then if I process again, then I just process the one that happened been processed yet. So the problem with this is because like I cannot really put the DB update inside Ractor because of the same problem that I mentioned before with my connection pool. Because like in IDB, then I also need a connection to connect to any or the connection pool is still any update to this need to be moved outside that cannot be done in a parallel. Like this is something that we will investigate and see how can we move it so Ractor can do like the update. Okay. Okay, so I think that pretty much it I thought. So some takeaway from it. Ractor is a pretty great tool for achieve algorithm. We can easily like think just change it maybe like in one day, and then my really improve like work system is like really improve. So previously we only process like I think 20,000 user per minute. Now we can encrypt like 40,000, and then the job that previously done like 1 now is 30 minutes. So it's great. And then the Ractor interface thing quite easy to use. It's very similar to Thread, almost the same as Thread. So like familiar with Thread, then basically it can be played in some like if the Thread is like included. The problem with Ractor is like it's still unstable and a lot of tuning necessary to support complete. For example, like the thing we try, like if you can have something like psychic for Ractor, then like we can we can like beginning to slide. A lot of instability is still in Ractor. So for example, one issue I have when running it is like it mess up with the dead weight. The them schema where somehow the load order is not correct and require like exact way then require the multiply lot somehow I apply Ractor. In some cases I cannot load and I need to spend 3 4 days debug that each but like wasn't able to do. So the code out work again. So I think there is still stability over there or some cases. Very rare cases though. So yeah, so that's all for my talk. Thank you everyone for listening.
Thank you so much for your sharing. Do you have any question for him? Oh, yeah, you have a lot of questions. You first.
Do you think the combination of vector plus fiber can be a serious replacement for process and thread? If so, what do you think is the main thing preventing that from happening now?
In long term, that definitely will be a replacement for processing. I think the major problem right now is just like the instability of implementation of Ractor, and we haven't decided like what the best interface so we can use it, and a lot of like issue with like mutable, shareable, constant. Ruby team is still dealing with. Can resolve more of that, then I think we can like I feel on top of that, eventually like replace our tooling with it.
Well, thank you so much for your question and your answer. Yeah, you are the next.
Thank you. So
So I wanted to check because earlier you mentioned that we can send data using can we just send the object as a message to the Ractor?
Yes, so it can solve the problem in some cases, but cannot solve it a lot of others. So in this case, for example, like user for user, right? I can send the user inside the, but in this case, then user when on a method that user a global state, then it be deep, like much deeper, right? I need to like be able to change the to hash method in global state over there, and only after that I can send the global state via the message with inside. That makes
Here for your question. Anyone have question for him? Oh, we have like 10 minutes now, so you can relax and ask him any question. People ascend the company. Yeah, any question for the company or for him or for the topic is okay. Okay. Yeah.
Is there any incident regarding to apply Ractor? If there any incident regarding apply Ractor in production, like
there could be like an incident where like when we apply Ractor, right, some incompatibility, like some the extension doesn't work, doesn't load for some reason suddenly. So we need to reverse that. And somehow when we upgrade the version of the gem, the version of Ruby, like 3.2 to 3.3, it is
okay.
Hey, thank you. I think any other question? Thank you so much for your sharing. Okay. And, our next speaker gonna be the Stephen Marham. Talk about how and why to run SQLite in production. But we're gonna move to the 405 to listen to his presentation. In like you should be there before for 10 minutes. Thank you so much.